Fellowship of the Broken, Making Sense of 12-Step Recovery by Angelo. Chapter 3. Binary. Those of us who have grown up with the evolution of computing will be familiar with the understanding that the entire world of digital applications is ultimately based on binary. The base 2 numeral system, or binary numeral system, uses only two symbols, typically 0 and 1. Although the idea of binary existed in ancient cultures such as Egypt, China and India, it was not studied in Europe until the 16th and 17th centuries, and it was only in 1937 that Claude Shannon produced his thesis at MIT that combined Boolean algebra with binary arithmetic using electronic relays and switches. This formed the basis of the extraordinary growth in computing power and complexity that we have subsequently witnessed and benefited from. In simple terms, a switch can either be off or on, representing 0 or 1. The original or natural state is off, or 0, and the created or existential state is on, hence 1. Each 0 or 1 is called a bit, and 8 bits comprise a byte, giving rise to 256 possible combinations. These individual combinations can then be assigned numeric, alphabetic or other meanings, and hence we have the basis for computer logic. In computer languages, this level of bits and bytes is known as machine code, which is created by a compiler layer of software, such as assembler. Higher level languages such as COBOL, Fortran, Pascal, BASIC, C, C++, Visual Basic and Java can then be used to write programs in what is called source code, which are then converted through a compiler into machine code. Operating system software such as Unix, DOS, Linux, Mac OS and Windows also convert into machine code in order to manage hardware and software resources. We also have operating systems for smartphones and tablets such as Android and iOS that also work on the same basis. Then we have HTML, CSS and JavaScript that provide the building blocks for the World Wide Web. All of these languages and operating systems translate down through the various layers to produce binary. Combinations of bytes also produce the possibility for data storage and retrieval. Familiar terms arise as 1,000 bytes combine to produce a kilobyte, and 1,000 kilobytes produce a megabyte, and 1,000 megabytes become a gigabyte, and 1,000 gigabytes equal a terabyte. Again, all of this is based on binary. And data transmission is also based on binary, with internet speeds and data transfer rates being measured in megabits per second, where a megabit is equal to 1 million bits. The transmission of data is simply the flow of binary between devices. So the entire digital world that we live in and depend upon is based entirely on binary. Indeed, the word digital in this context refers to data or signals expressed as a series of the digits 0 and 1. It seems incredible that diverse and sophisticated applications such as Google, Facebook, Amazon and Netflix, as well as equipment such as desktops, laptops, servers, smartphones, tablets and digital cameras, all owe their functionality to unimaginable quantities of zeros and ones. all of this complexity is based on such simplicity. Imagine if we were to give a smartphone to a group of scientists who were unfamiliar with digital technology and ask them to produce a thesis on how it all operates. Separate groups would look at how the applications work, how the information is stored and retrieved, how the underlying logic fits together, how the calculations are processed, how the device is managed, and how the data is transmitted. These discoveries would then lead to studies of the internet, server farms, GPS, satellites, and goodness knows what else. Theories would be developed and experiments undertaken to test their validity. After an inordinate amount of time and effort, all of this research would ultimately distill down to the remarkable discovery that the incredibly complex and multi-layered digital world originates from and is entirely based upon the simplicity of binary. This hypothetical study is, for me, a good representation of the world of scientific research. The fields of physics, chemistry, biology, and many others have made tremendous progress and produced countless wonderful applications to make our lives longer and easier. All they are doing ultimately, however, is trying to understand what is already here. The research continues, of course, and will never end, but science has come far enough now to realize that the mind-blowing complexity of the apparently real world that we experience must ultimately be based on utter simplicity. It's worth reflecting that the digital world that we inhabit has been invented, designed and implemented by human intellect, and that it continues to evolve. The understanding that, in reality, it's all a multi-layered expression of the underlying binary is difficult to believe, yet it is nevertheless true. The advantage of the binary metaphor is that we already know in advance that zeros and ones are the ultimate source, because that is from where it all originates. It's perhaps more difficult to accept that the underlying nature of our experience of reality is also simplicity itself. Yet science is slowly revealing this discovery. It does now seem logical to conclude that there is an ultimate source of the relative world, whatever that source may be. Returning to our understanding that digital applications are created using multiple layers of software, we can immediately see how mistakes or software bugs can create potentially difficult problems to solve. If a mistake is made at the surface application software level, then it can be identified and corrected at that level. The problem is identified, traced in the application software, and fixed. If, however, there's a mistake made in the way that the application software translates into source code, then the problem is further down within the layers. The resulting problems will manifest at the surface, but the real problem is deeper. No amount of fixes at the application software level will ever solve the underlying mistake. If an error is made even further down at the compiler level, where source code is converted into machine code, then obviously it will not be possible to resolve the resulting application problems by making changes to the application software or to the source code. The mistake has to be corrected at the level where it is made. It may well be that there are no bugs at all in the application software or source code, but the application will nevertheless malfunction due to a bug at the compiler level. The problems will appear at the surface, and it might be tempting to try to fix them by making changes at that level, but it will all be to no avail. Even if changes at the surface level seem to solve some of the issues, such successes will be misleading because the underlying mistake will remain unseen and unresolved. The only effective solution will be to correct the underlying mistake. The obvious purpose of this binary metaphor is to introduce and emphasize the fundamental idea that complexity arises from simplicity. In order to understand and address a complex problem, it must make sense to dig as deeply as possible and implement a solution that is effective at the level at which the problem arises. The difficulty here is that a simple solution to a complex problem may seem inadequate and therefore unbelievable. This is particularly true when it comes to addiction. In truth, both the problem of addiction and the solution are simple, but we're going to have to cover a great deal of ground in order to fully understand this. Recovery from addiction can seem beyond our comprehension or reach, but this is not the case. The solution is simple, although invariably not easy. It all boils down to a simple decision. Do we want to recover? Yes or no? Do we want recovery, or do we want to continue to suffer? Addiction manifests uniquely in each of us, yet there are often many similarities beneath the surface, and the deeper we go, the more similarities appear. When we get to the source, we will find that the problem is common to everyone and really simple, and so too is the solution. Recovery is a binary decision. We are each entitled to make this decision for ourselves. If we decide that we do want recovery, then we must be prepared to go to the source of the problem. It really is that simple.